Hello, everybody, and welcome to the Dimension sessions of this year's DS Showcase. Before I share a little bit of the history with you, I want to introduce to you Isabel Thompson and myself. I will only get to speak a little bit about the history, while Isabel is able to share the exciting news of our today's launch of a new Dimensions module with you. In order not to waste more time, let's get started immediately. Research makes a difference. We know that it changes lives for the better, from the phone in your pocket to vaccines. Everything starts with an idea. And for researchers to stand on the shoulders of others, the ideas of these others needs to be shared globally and equally. And in today's tough times, it's researchers and their organizations, both public and private, who will help to solve, hopefully short-term, the big problems we are facing currently, and also the long-term challenges or opportunities which come out of it. All the innovations that we see from the research sector are supported by hundreds of decisions from researchers, from administrators, strategists, policymakers, and funders. And to drive these decisions, they need to be based on the best evidence possible. So evidence and context for a decision matters. And that is why we started to work on Dimensions about 4 years ago, and we launched it 3 years ago. And at this point, the focus was mostly on publications and citations. And the Dimensions team wanted to change this so that more context and more information is taken into account, so that it is possible in one data infrastructure, in one tool, to see the entire trajectory from resources being input into the system, grants, research happening, preprints being published, data sets being produced, the publication as a cornerstone, the immediate feedback via social media captured in Altmetric, the feedback of the research community via citations, and then the impact in clinical trials, patents, and policy documents. And in order to show all of this, we had to make the decision where we want to be on the scale from having high quality metadata and coverage. At the time when we launched Dimensions, there was PubMed for a discipline, Web of Science and Scopus as a curated source, and Google Scholar with broad coverage but a lack of metadata and not fit for every institutional use case. And so we decided that we wanted both. We wanted to have a broad coverage, not only publications, but all the other content types too, and a high metadata quality as much as possible. And that is how it looks today. We have 112 million publications, 5.6 million grants totaling up to 1.7 trillion in funding, 41 million patents, 500,000 policy documents, 1.5 million data sets, 600 clinical trials, and a lot of Altmetric data points. This is basically the content which we integrated, but the team cared most about the links between these content types, because those actually allow you, with the Dimensions data and the tools, to draw the link between what happened if a grant was given to a researcher, which publication originated from it, which clinical trials came out of this, and has the publication been mentioned in a policy document afterwards. But we didn't only draw these lines and those links. We also worked very hard to actually make all these different content sources from publications, clinical trials, patents, and others to form them into one consistent database where we do concept extraction, we disambiguate researchers, institution identification, categorization, and reference extraction in order to bring all of these sources and this information into one harmonized database ready for analysis. So we have 17 million plus concepts, 65 million plus researchers, 100,000 organizations disambiguated, 10 different classification systems, and the references extracted between all of these content types. And up to today, the users were able to access this data infrastructure through 3 means. The web application, which is even in a free version available for the individual researcher at no cost. to allow searching, to see specific analysis and visualizations. The API, which is a little bit an unusual API because it doesn't only allow you to extract data, but also enrich your own data, allows ad hoc analysis, topic modeling, full text search, and others, and is meant for data and analytics teams or those users who actually want to get their hands on the data. As the third delivery option, we always had bulk data available. That was a delivery of large JSON files, and the client had to actually integrate it into a technical infrastructure, which was complicated and also expensive because it then needed to be maintained. So very few clients were actually in a position to get their hands on the raw data. But we always wanted to make the full data set accessible in order to enable the users to actually use the data in the ways they want to use it. But the bulk data, as I said, has high infrastructure and technical requirements. So we always asked ourselves, how can we lower these barriers? How can we get people access to the full data sets so that they can answer the questions they have without being constrained by interface capabilities or by things which are not as easy to do with an API? And actually, the most important question, how can we do this at scale so that it's available for all clients, not for only the most well-resourced ones? And today, we are going to launch a fourth module, as you can see here, between the API and the bulk data. And Isabel will now tell you more about it. The only thing which is left for me to say, that the excitement of the team resembles a little bit the picture you see here. And with this, I'm handing it over to Isabel. Thank you.
Thank you, Christian. I am very, very excited to be here with you today to share this next step. And I'm going to share my screen so that I can take you through the slides we have prepared. So yeah, I couldn't be more excited to be with you all today and to invite you to take the next step with us on a journey which makes research information as accessible as it ought to be. And we hope also to give you a new perspective on what it is possible to do with that data. Across the whole research and innovation ecosystem, everybody needs data that is ready to go. It's an incredibly complex and nuanced ecosystem, and we need to have the largest amount of information available, but in a way that you can get to the answers that you need as quickly as possible. We're all here, we're here on this session, we're here in our jobs because we care about research and we believe that research makes a difference. So when we're working in this ecosystem at all, we need more of the research life cycle. You know, that's what Dimensions has been all about, but it's also a complete necessity for working here. You've got to understand the interplay between all the different players and how research goes from initial government funding through to the later commercialization, through the universities, the partnerships that make it is what it is. So you have to have more of the research life cycle. You have to have, to do that, more data points and more links so that you can fully understand it. And all of that leads you to more insight. And so what Dimensions aims to deliver is this greater evidence base for decisions that gives you confidence and context around the piece of information that you're trying to understand so that you can make the best possible decision. Yes, Dimensions has had this data and we've already made it available in a good number of different ways. However, it hasn't been ready to go. It hasn't been completely ready to go in the way that it perhaps could be. You may not have realized this, but we realized this because we always wanted to make it more readily available. And so by ready to go, what we mean is that it has to be available fast. You need to be able to extract the insights you want out of it really quickly. It has to be on demand. It can't, you know, the information can't come 2 weeks later or after even several hours. Some of these decisions are time sensitive. It obviously has to be interoperable. We're all working across multiple different systems, multiple different data sources. And it needs to be ready for analytics, and it needs to be ready for AI. Once you have the information that you want to analyze, you don't then want to spend time cleaning it. You want to get straight down to the analysis. And that is what we've wanted to deliver. And we searched high and low for the infrastructure that would let us do this, because it's actually not a trivial task. And what we have decided to do, and what we are launching today, is a partnership between Dimensions and Google Cloud to bring you Dimensions on Google BigQuery. What does that mean? That means we are giving you direct access to all of the underlying data of Dimensions. What does that mean in practice? It sounds like something that's much more open and accessible, but what does that really mean? It means that you have now ultimate flexibility to analyze the data however you want. You can do any query of it you want. You can ask and answer any question of the data that you've always wanted to ask. It means speed and agility. BigQuery is incredibly powerful. It's designed for working on massive data sets like Dimensions. And in fact, it means you can aggregate and manipulate data at a speed that was simply impossible before. And you can now create bespoke and even real-time insights. And lastly, it means incredible interoperability with other platforms and data. BigQuery is a generic cloud platform which is designed to integrate across different clouds with existing infrastructure. So you can integrate it with your existing infrastructure. There's no need to change anything that you're doing already. You can join it now directly with your own data. You can analyze Dimensions alongside your own data. And you can pull Dimensions data directly into your visualization tool of choice. There are now no restrictions and no barriers. I'll step back a little because not all of you may know what BigQuery is, and I'll give you a very high level overview. What is it? On a more technical level, it's a multi-cloud data warehouse. What that really means is that is a analysis platform, an analytics platform that is designed essentially for incredibly fast analytics on massive data sets. I tend to think about it in more human terms that are more easily understandable. So for example, if you're a person, like I believe we all are, you can very easily come up with questions of the world that make intuitive human sense. For example, which companies are citing my research in their patents? It's so easy to ask that question as a person, but it's actually a surprisingly difficult challenge to extract that out of a database, which is structured very differently from a human mind and obviously contains enormous number of data points that you have to slice and dice to get to the insight. BigQuery was originally a Google internal tool, and it was designed for exactly this type of question. It was designed for very quick slice and dice on large data that got you to answers. And so it is ideal for analyzing a huge, incredibly flexible database like Dimensions. There's something else that BigQuery offers as well. It really eliminates the need for any expensive local server infrastructure and the technical resources that you might need for some kind of big data system. You may not think about it, but Dimensions is big data. It is enormous. I've got some stats on the next slide of how big it is. And because it's so large and because some of the queries can be very complex, if you use just local infrastructure of any existing database that you might have internally, it tends to be the case that some queries will always be out of scope, even if you had the data internally, because they will take too long, they'll be too complex, they might be too expensive. For these types of large queries, you need a cloud infrastructure, which makes essentially all of that go away, and you don't have to worry about the infrastructure at all. You write a question and you will extract the answer in only a few seconds, even if there are billions or trillions of data points. So it is, you know, infrastructure as it should be. It basically helps you get the job done, but you don't have to worry about it. And that is an impressive thing in itself. So as I mentioned, Dimensions is huge. We work with a lot of data every day, but actually a lot of it is small data, whereas Dimensions is big data. And that's because building context for decisions is a big task. We have hundreds of millions of documents, and we also have nearly 1,000 fields that describe these publications, from names to locations and addresses and IDs. And this results in 1.3 billion links, possibly more than that now, in fact, and 33 trillion data points. And if you have that data, you can think of the combinations, think of the questions that you can ask of it. There are pretty much, start to be verging on infinite possibilities for the kind of questions you can ask. But it always helps to have some example of how that becomes useful. So what Dimensions on BigQuery actually really offers you is the ability now to view and analyze Dimensions data however you want. It's the same data that you've known previously, but you're not restricted by any particular web app now. And more importantly, you can even pull that data into new dashboards or a report that provide answers on a specific topic. So you can see here one, which is a patent report we've been working on. You can do this easily for any university, but we have Stanford here being famous backwards and forwards with industry, so that's why I picked them. And you've got some questions: who's building on their research, who's filing patents that cite Stanford's publications. And if you do this query, you find, if you look at this report, you see there's IBM and there's Apple and there's Microsoft, there's a whole load of pharma companies, and you start to get an impression of Stanford's role in industry. And an organization can understand its industry relevance through the lens of patents like this. But you can serve it up at the level of a university, you can serve it up at the level of a journal. You can serve it up as the level of a funder or a grant. You can now pull the data together in a way that is useful for a specific person on a specific topic. And that was Dimensions data. But what's really good about BigQuery is that you're not just limited to Dimensions data. You can add in your own data. No one's expecting Dimensions to have all of the answers, because a lot of what becomes really interesting is that context for your existing data, your existing systems. If you're doing benchmarking, for example, you might have all kinds of internal data that you want to benchmark in a global context. So with BigQuery, you can join Dimensions securely without sharing any information with us at all. You can join our data directly to your data. And you can also start to expand Dimensions and your data out into other external databases. One reason that we picked BigQuery is that it has a growing ecosystem of research and science and research data sets, over 200 in fact, that are already available on it for research. So I picked out here Chembl, which is small molecules and patents. And what you could do, for example, is start to look at the grants in Dimensions and look at, say, an NIH grant and see how what publications that has resulted in. But now you can expand it into what therapeutic areas has that had an impact in, what drugs have resulted from that grant. And we can start to extend Dimensions out into an even broader and wider context. And on top of that, you can do all of this. You can do the custom dashboards, the queries, the joining with your own data in the tools you already use. So whether you're using any sort of visualization tool, Tableau, Click, Power BI, or if you don't have one of them, Google Data Studio is free. You can now connect BigQuery into your existing workflow. If you work programmatically and you want to uses Python or integrates dimensions through a Jupyter notebook, you can also do that directly with BigQuery, which has a whole load of client libraries. So this is very exciting. It's incredibly exciting, but it is also quite abstract. So I want to demonstrate to you what a kind of game changer this is, and also how easy it is. And so I have the dubious pleasure of doing a live demo. You never know how that will go, but it should be in itself very smooth. I'm just going to exit this, go straight to here that I have received earlier. Okay, so this is Tableau. I thought I would show Tableau as being a very well-known tool, but we could be using any visualization tool that we choose. I have here a blank worksheet. And if you've got a blank worksheet, you probably want to pull some data in to start analyzing. To bring dimensions into Tableau, it takes less than a minute. You can now simply press this plus button and go to connectors. Straight away, you can see Google BigQuery. And you can also see a lot of other data warehouses and databases to show how easy you'll be able to analyze dimensions alongside existing data sets. But right now we're interested in dimensions. So I click Google BigQuery. I'm taken to this authentication page. BigQuery uses Google authentication. This is the account that I use with BigQuery, and it has access to the dimensions datasets. So you would find it as easy as well, just to click your address and click allow. And immediately you have dimensions in Tableau. It is that quick. It's as if the data were in your own infrastructure, but it just happens to be on the cloud. So you can go, in fact, from not having access to dimensions at all to having the data in Tableau in under 5 minutes, because we've worked on all the magic behind the scenes so that the sign up is very, very smooth, and you can start working with it straight away. Let's do an analysis. Let's pick clinical trials, because they're on our minds very much at the moment in the global pandemic. I click clinical trials and I drag it here to where I'm going to do an analysis. You can see clinical trials here. And along the bottom, you can see all of the fields that we have for each clinical trial. For each trial, we have an ID, a title, abstract, what phase it is, the gender of the participants, so whether the trial is involving both genders or just men and women. We have the publication IDs, the publications that the clinical trial cites. We have a lot of other fields, but I won't show you all of them because we want to do the analysis. So we've brought the data into the system, and now we want to analyze. In Tableau, you do that by going to a sheet. And you can now see that the items that were originally along the bottom are now to be found at the side in alphabetical order. So at the top, we can see abstract again, and you can also see a number of categories. We categorize our clinical trials in the same way as grants and publications, patents, so that you can do continuous analysis across the whole data set. So you can see things like field of research code. We have cancer types and disease categories. We also recently launched the Sustainable Development Goals, which is a new thing with us, and as you can see, it's already available to work with here in BigQuery directly. But what report should we do? A good start is probably something as simple as distribution over time of clinical trials. So to do that, I take start year, which is here, and drag it up to columns. We then want something to count. So I take clinical trials and drag into the row. And you get a very smooth count of the clinical trials that are available in dimensions. We index a large number of all the biggest clinical trials registries globally. And I think it's interesting to see the big uptick in what is available from the late 90s when we start to see a digitalization of this type of content. But to look at a more manageable, more recent years, that will be more informative. So I'm going to simply filter. I'm going to look at the last 5 years, which seems like plenty. And in fact, there are some clinical trials that are already planned for 21 and 22, so we'll include them as well. And here we have a graph of the total number of clinical trials in dimensions over the last 5 years. At this point, we might want to dig a little bit deeper and break that down. So I mentioned gender on the previous page, and we can take gender here, and again, just drag that into the rows at the top. It will create 3 graphs, but it's very easy to select this option to do a stacked bar chart, which is more useful. You can now see how the total number of clinical trials are broken down by gender, by the gender of the participants. As you would expect, we see the most clinical trials are performed on both genders. And interestingly, we see that there are more clinical trials involving participants that are only female as only men, which I think is interesting in itself. It seems that women are being experimented upon more. But it might be interesting to take one step further from this initial analysis. This analysis is in fact something that is difficult to do in the web app, because we provide the filter in the web app, but it's harder to get to a trend over time like this, because there's only so many things that you can do in a web app. You have to make decisions which ones are going to be the most popular or useful. And this is the kind of thing that you can now explore more freely when you have access to the full data. But if we take one more step, we could add in another interesting data point, which is easy to bring in here, which is the Altmetric score. This is the attention that has been given to a subset of our clinical trials in our database. The total score isn't particularly informative here, but it's more informative if we take an average. Because what we see now is the average Altmetric attention score, so that's picking up in news articles, tweets, blogs, and such like, for clinical trials with different genders. So we can see here that the number of clinical trials for men, they actually receive a higher Altmetric score, a higher level perhaps of public attention than clinical trials involving women. And that raises a whole load of questions. We could go in and explore that more with all of the other fields that we have, try and get to some answers, see if there is any correlations or trends that we can see. But we have the start of a data story, and we've got an insight in itself, an insight that would have been slow, if not impossible, to do in the web app, and even with the API would have taken quite a lot of programming. But now, with access to the whole data set in a familiar visualization tool, becomes incredibly easy. So I hope that gives you a feel for what I was saying about the flexibility and the simplicity of working with dimensions in its new format, how many new opportunities it opens up. Unsurprisingly, we have a lot of research lovers and data people in-house who've been loving getting their hands on this. We have an initial dashboard here. In fact, this was our lead engineer from the BigQuery team, Jared Watts, put together an example of an overview of his department at one of his previous university. And you could take this and then you could benchmark this department against others globally if you wanted to see relative performance. You're not just limited to Tableau. This is something that Simon has been putting together using Lingo 4G, which is for large-scale document clustering. In BigQuery, we're making available all the abstracts, and you've got the title, and we've got 70 million concepts as well. So you can really start to understand the subject matter and the meaning and the links between topic areas within the whole database at an incredibly granular level. We hear an overview of the wine industry, but you could imagine this for being any topic that you're interested in, biological, history, economics. So in summary, we now have the data that you've been using, but that perhaps have not been able to fully exploit in all the ways that you want, in the most flexible option yet. It is direct access so that you can do advanced analytics, you can do dynamic dashboards, you can do any form of custom reporting that you want. You can join it with public and private data to expand your context into a bigger global picture. You can integrate directly with business intelligence tools, other data visualization tools. And we hope that this will be particularly appealing to data and analytics teams, people who want to get their hands on the data. But also what this really enables is the kind of custom dashboards for anyone in an organization, whether it's for a vice chancellor or a dean or an editorial assistant or a grants manager. You can now serve up the view on the data that delivers the most insight to them at the point that they need it, so that you can have the insight you need for a better, more confident decision. We've been thinking here, what could be the barriers to people, and how do we get rid of them? So first of all, what if people don't have infrastructure? Well, we chose BigQuery because none is needed, because it's on the cloud, it is completely fully managed, it is plug and play. You only have to log on essentially, and you can start exploring immediately with no needs for setting up a complex infrastructure. If you have existing infrastructure, then as I've shown you, BigQuery lets you plug dimensions in to any existing systems or tools that you have. And it's also multi-cloud. So if the data sets that you have in AWS or Azure that you also want to analyze with the BigQuery analysis speed, then you can do that directly as well without having to move your data around. If you've got other data, well, yeah, of course you do. What we understand is that obviously in the research ecosystem, no one is going to have all of the data that's needed for a particular decision. We're all part of something much, much bigger. And so we have designed this infrastructure and the data to be as interoperable as possible. We picked BigQuery because it's interoperable, but we've also built dimensions from the very beginning to be easily interlinked with other data sets. It's why we chose grid IDs and ORCID, and the whole backbone is all open metadata. And then we also use things like FOR codes and standard disease codes so that it can link with other data sets. Ironically, for all that linking, we haven't had the infrastructure that's allowed people to do it before now, but we do now, and we look forward to seeing what people can start to do when they merge the data with their own data sets. And lastly, if you don't have that many data analysts or even any, then again, we want to lower those barriers as well. So we have a library of queries and dashboards. You've seen some of the visualizations already to get you started. So there are things that you can work with straight away, particularly around use cases that we know are important to people that we work with. Or you can obviously work with our consulting team on building particular dashboards. BigQuery is particularly is really useful for across the things you might want to do with dimensions, but I thought in case there weren't things that have been made concrete enough, I'd pick out some of the examples that people have already started doing with BigQuery. One is competitive intelligence, the ability to have a summary very quickly of what competitors or peers might be working on, who are they working with, what's their latest research, what direction are they going in. The ability to do flexible benchmarking at the level of an organization, a department, an individual researcher. You can also look at a publication. You can benchmark a publication's performance or a grant, and you can see how it compares with others across the whole corpus. You can look at rising stars, emerging researchers in particular areas, or key opinion leaders that move a field forward, find out who they are. And you can also quite easily target and discover people who might be important for recruiting to build out a team expertise in a particular area. Something that people have been starting to do immediately also is looking at academic and industry partnerships and collaboration to find partnerships on specific or niche topics that would be particularly productive for both parties. And also impact analysis always. This is actually an example of how BigQuery opens up a whole new space as well. So beyond the stuff that we have around looking at commercialization and patents or clinical trials, policy documents, you can now also link with economic data sets if you want to have an understanding of how research or funding is playing into GDP or other economic indicators. You can pull this all together in a single dashboard now. You can also look at emerging research trends, horizon scanning, have a list of emerging technologies from virtual reality to the most important recent COVID biomarker that might have been discovered. You can have this in a dashboard or do very granular levels for working out which technologies might have reached a point of commercialization that makes them interesting to track, that we might see start to be brought to market in industry, for example. You can also look at trends around one example, behavior shifts. You could look at open access behavior shifts. How are people starting to publish now? We have increasing numbers of transformative deals, or how is the funding affecting how people are publishing? And you can aggregate, as I mentioned, all this at the level of an organization, a topic, a journal, a researcher, any angle that you want to look at this. And then lastly, BigQuery is, as I said, designed for really large-scale analysis. So you can do co-citation analysis, and you can even define your own citation graph. And you can use it to create new metrics and indicators, even across hundreds of millions of documents. These new metrics can now be created with complete transparency. So this is something that we're quite excited about. If you can't wait to try it out, and I hope at least some of you will want to get your hands on this straight away, we have made the Dimensions COVID-19 data openly available on BigQuery. As you'll probably know, we've been trying to work with the research community as much as possible since the outbreak of the pandemic. We've written reports, we've shared insights, and now we've made the data, which was getting actually very large and too large for a Google Sheet. We've now made this available on BigQuery so that you can both experiment with the data and see what it's like, but also perhaps to get to some insights or ideas for new research that you might be able to discover, see any trends. And we've also provided a new interactive dashboard to demonstrate if you're a bit less technically minded. We'll be sharing this in the chat shortly, so please do take a look. We've got, you can click on different things, like if you want to click just on economics, you can see publications and clinical trials that have been just on a particular subject area. And I think this is a good moment to do a huge thank you to the other two core members of this team, without which none of this would be there. Michaela Hassan has made this report, and you might know him from the API, the amazing API lab and all the training. He's also now been leading on showing what can be done with BigQuery and marshalling us all into to get everything live. And then the other person I mentioned earlier was Jared Watts, who's the lead engineer on this. And I showed you how easy it was to play around with dimensions in Tableau. The amount of work that and verging on magic that Jared has put together to make everything behind the scenes so that it's that easy to work with requires, I think, a special thank you. So yeah, in summary, we're really excited. I'm excited by the possibilities, but I'm more excited to see what kind of things that people will be able to discover in our data. We only have so many ideas ourselves. And in summary, for dimensions on BigQuery, it's all the context that you need in the place that you need it. And it's there to be fast and on demand and to give you the fuller, bigger picture on this incredibly complex and important ecosystem so that you can have the information you need for better and more confident decisions. And I would like to thank you and make room for some questions.
Thank you very much, Isabel. There are a couple of questions coming in, and also some voting has happened.
I couldn't see anything
so let's go. So, just to start off the top real quick and answer some of the questions, can you do the same analysis? Can you do the same for specific topics or queries? Yes, of course, you can do specific queries to narrow down the field and then look at this one. And the question number 2 was whether other data can be blended. Other data sets from other platforms can be blended into the analysis so that you can connect it. And I think that has been answered by Isabel shortly after the question came up. So yes, that is possible. That was one of the use cases why we actually implemented Google BigQuery to give you this flexibility. Question number 3, in terms of votes, was how often are each data sets updated? We are updating daily. So it's actually at the same frequency as the general dimensions application as well. The next question in terms of votes is whether the Google BigQuery is included in the core product fees or as an update, and it is not included. It is an optional module which you can decide to take or not, because we do not expect every organization being interested in terms of fairness. It would be not right to include it right away. How do you disambiguate items, people, institutions, things, and events? It is a algorithmic and disambiguation for researchers, for institutions. We are using the GRID database, which we developed and made openly available in order to harmonize the different institution names to a persistent identifier and match them to one organization. It's a little bit a broader topic, which would warrant a call in its own. So I'm happy to discuss that more in a bilateral conversation. Do you need a Dimensions API or just an account to be able to connect? So if you want to start using Google BigQuery, it is a separate account which we will then create for you so that you can connect your Google BigQuery account with the Dimensions data. Did I phrase that in the right way, Isabel?
Yes, I would say so.
Good. And then there's a question, I think, which is where you have more expertise than I do with whether Tableau Online equivalent is Tableau Online equivalent to Tableau Public, or is data analysis private to the user?
Tableau Online is their software as a service version. So it's the online version of Tableau Desktop for people that used to install it. You can publish publicly through Tableau Online into the public portal. So you could analyze some of our free COVID data, for example, in Tableau and publish it to the public Tableau dashboard set.
Great. So in when initially connecting Google BigQuery and Tableau, a specific Google BigQuery dimensions on Google BigQuery credentials are required. I think Michaela answered that also in the comment section. The next question is, you're thinking that this will replace the bulk data option mid to long term. We actually will continue to provide both, because also for the bulk data, there are specific use cases and clients who actually prefer to receive the data and this way have built infrastructure on top of it. So we are not planning to eliminate bulk data at all, quite the opposite, but are excited that we now can provide more access, more users with access to the data.
Yeah, and I could just jump in, Jim. One thing I'd like to add there is I was quite surprised when I started working on this that the bulk data has often taken clients 6 or 9 months to ingest, because you're building a whole data pipeline. And so what BigQuery does is, yes, some people will always want the bulk data internally, but for people that don't, you now don't need to build any sort of infrastructure or data pipeline or work with developers to ingest that data. You can just log on with an account and a password and start analyzing it straight away. So these meet different use cases.
So the next question, will the recording of this presentation be shareable with others in my institution who did not register for this event? Yes, they only have to register, and then they can access all the recordings of the digital science showcase, which will be available on this site for, I think, a month. So quite easy, and if you need it afterwards, just reach out to us. Then perhaps a question for you. We are also a little bit at time. So Isabel, do you have to use BigQuery? What if you have a different engine you prefer to use, e.g. Palantir or Kensho?
It depends on the exact one and how you want to integrate with it. As Michaela said, the one that we are explicitly supporting is the format in is all the data in the BigQuery format, which has its own table format. We are considering expanding out to some other platforms, analytics engines as well, based on demand. So please do let us know if there's another option that you want. Some of the ones mentioned may also work on top of BigQuery, so it can depend.
And then there is an interesting question. Can you do analysis using specific types of publications, for example, publications that are indexed in Web of Science and Scopus, or publications that are in a specific quartile in Scopus or Web of Science? And the answer is no and yes. So we don't have the information about the Scopus publications in Google BigQuery, but if you happen to have the information from Web of Science or Scopus in a table, you can integrate it on your private site into Google BigQuery to exactly establish this match and actually work with it. So while we cannot provide it because we don't have access to this data, you are able to actually connect it if you want to, using the dimensions on Google BigQuery environment. So I think there are 2 more questions. Is the product available as a standalone? I think you can prefer only to use Google BigQuery, obviously, but so far we actually have received the feedback that the mixture of a web application, the API for specific tasks, and Google BigQuery for others is what actually most clients would like to have. And there's one more. Yeah, go ahead.
Very briefly add to that that's because you might again use them slightly differently. BigQuery is for this slice and dice. The API is the best way to get out the full text search. If you want to search and then analyze, you'll use the 2 together. We're building a workflow especially for that. And lastly, the web app can integrate quite nicely with a BigQuery dashboard. So if you click on the COVID-19 dashboard that is slightly further up, you'll see that you can link to a paper in the dashboard. So you've got a dashboard that's been built with BigQuery, but it links to an individual publication or clinical trial or grant that you can then explore more broadly in the web app. So they do work together as well as individually.
And there's one more question on Tableau, follow up on GBQ Tableau Online. When you publish analysis, is it public to the world or can it be shared to a limited group of viewers within an institution? I think that is up to you how you actually choose to work with Tableau. So thank you very much. Those were all the questions. I would like to say at the end, thank you for listening, and thanks for being with us for this launch of this exciting new module. Thank you, Isabel, and the team. If you would like to learn more and actually explore the functionality more in detail, we are always available to walk you through it more in detail. Just reach out to us on any channel. We love to hear from you. Thank you very much, and I wish you an interesting DS showcase throughout the rest of the week.